Okay, Assalamualaikum and good afternoon to everyone. Salam sejahtera. Can you hear my voice clearly? Can someone respond to my voice?
Boleh,
Yes,
doktor.
Boleh, boleh. Okay, so there is an international student who just joined this class. So from today, maybe I will deliver my class fully in English lah.
Thank you, Doctor.
Right? Okay. Okay, so shall we start now?
Yes.
Right. So it's good to see you again, even though I cannot see you from your camera. Right. So this is the third week of lecture, and we'll be moving on the second topics of design of electronic equipment, which is drawings. Share my slide first. So today we move on the second topic, which is drawings.
Doctor, sorry to interrupt. Just in 1 minute, what was covered last chapter, just to follow you in previous sessions?
In previous session, I will upload the recorded video from WebEx. I will share the recorded video.
Okay, thank you, Doctor.
Yeah. So since this is the third week of lecture, so I will not go back to the previous topic. So for those who just joined this lecture, this course, I will share the recorded video, the WebEx recorded video in WhatsApp group, so that you can follow the lecture, the past lecture from that recorded video. Right, so from now on, I will be moving on the second topic, which is drawing. So basically in this course, we have all 6 topics, 6 theoretical topics to complete. And this is the second topic out of 6 topics that we have overall. So hopefully we can finish the theoretical aspect of this course within 6 or 7 weeks of lecture. All right, and then after that, I will announce about the practical lecture that I will do it later. So for the practical lecture, I will announce later, and then I will prepare the module and share with you all. Right? So in this topic, the second topic, drawings, so we expect that the student will understand on how to differentiate between mechanical or architectural or electronic drawings. So basically in technical point of view, for example, as an engineer or technologist, when they develop something, they will refer to drawings. For example, in electronics, we refer to electronics drawings. So drawing is like a birth certificate. It's like a birth certificate. If we want to produce product, we need to refer to the drawing, all right? So there are many types of drawing, including mechanical drawing that is normally used by mechanical engineers. Sometimes architect produce the drawing that is referred by the building contractor to build a house or a building, right? So for the electronic, we have the electronics drawing, but normally not all of the component used in the electronic drawing is similar to those used in the electrical drawing. So basically, even though electrical and electronic are close, but normally in terms of drawing, basically we are referring to the different types of drawing. Like software, for example, we use different software for electronic and for electric. Okay, so I hope that you can differentiate between, in this case, we consider mechanical, architectural, or electronics drawing, right? So the second one, hopefully at the end of this topic, you can understand the 10 drawing sets. What are 10 drawing sets? I will brief it about it later. So basically, in every step of design of electronic equipment, for example, if we want to produce a PCB board, PCB circuit, the circuit that is produced in the form of PCB, we have different steps of development. For example, we start with design, and then we do the drawings, and then we do the prototyping and experiment, and finally we produce the final product, right? So in every step of development of the product, normally we do the drawings. So we refer to the drawings. So every part of that project development, we have different types of drawings. So number 3, hopefully at the end of this course or this topic, hopefully you can understand about the schematics drawing. So what is schematics actually is? Schematics means something that will represent an object or something using abstract. It's like an abstract. We not represent something in the form of actual object, but it is actually more to symbol or abstract of that element of system, right? So in a system, you have a lot of, in our electrical system, for example, you have some electronic components, but we don't represent the electronic component in the form of actual picture of that component, but we represent it in the form of symbol or abstract. So that is about schematic drawings. Okay. All right. So we have 3 units only to be completed in this topic. The first one is more to introduction. I hope you can see the laser pointer, right? Right. So the first one, which is 2.1, is I'm going to talk about drawing, which is more to introduction to the drawing parts. Okay. In the second one, which is 2.2, we will move on which is the most important part of this topic, which is the 10 drawing sets. Okay, I will brief on every part of the 10 drawing sets. So what are that 10 drawing sets? So we will be explained later. And then 2.3 is drawing procedure, just a bit about the information we put on the drawing. That is the drawing procedure. So the first one, so what is drawing? So in this case, we consider mechanical drawing, architectural drawing, and also the electronics drawing. So this is an example of the mechanical drawing. So mechanical drawing basically represents the projection of a 3D image. This is the 3D image which is projected into 2D image. Like for this one, it is top view of this object. And this one is the side view, I think. So this is the side view of this object. And this one is the top, the back view or front view of this 3D object. So from 3D object, we actually transform it into 2D object that can be drawn on a 2D surface, right? So this is basically about the mechanical drawing. So mechanical drawing or mechanical drawing software normally used by mechanical engineers. This is an example of the mechanical drawing software. Normally, Autodesk is one of the popular software that is used in many aspects of drawing. Many engineering fields use Autodesk-based software. For example, AutoCAD is normally used by the mechanical engineers to design the mechanical drawing, the mechanical parts, right? For example, in this case, in this drawing, you can see that a type of differential that is used in gearbox of a car or automotive. So this object is transformed into the true 2D dimensions here. And this is the side view, including the internal parts represented in this drawing. And then this is, I think this one is the front view of this 3D object. And this is the top view of this object. So Autodesk normally, in Autodesk, Autodesk is the name of the brand, the brand. So from Autodesk, there are many types of mechanical drawing or the modeling, modeling software that can be used for drawings. For example, one of the product is Autodesk Tinkercad, which is recently developed to facilitate primary students, which is an easy interface that can easily be used by the primary school student to develop their own project, electronic project, including the modeling of mechanical projects. Okay, so that is about mechanical drawing. And next is architectural drawing. So in architectural drawing, it is normally drawn by the architects. For example, the building contractor will be used this drawing to construct or to develop or to build the building, right? So in architectural drawing, it actually explains on how a structure is constructed. So this drawing is fairly realistic, means that we have the actual measurement or dimensions of this building. So similar to the mechanical drawings, right here, the architectural drawing also represents a different side of an object. For example, for this building, it shows the front elevation, and then this is the left elevation of that building, and this one is north elevation. So these are several types of software that is used for architectural drawing. So this is the SketchUp Pro, one of the modeling software that can be used not only to design a structure of a building, but also it can be used to design the what we call interior design or landscape design. So that is the SketchUp Pro. And the other one is Revit. This one is also from Autodesk. So an example of the sketch of a building here. As you can see, Revit is one of the software produced by Autodesk that is normally used to model or to construct or to provide the architectural drawing. Okay. So the third one is electronic drawings. So as you can see, for the electronics drawing, it is entirely abstract, meaning that we do not represent the component in its actual form. For example, I'm holding here is the capacitor that I have here. This is the actual image of this is actual capacitor. It looks like this, but on a paper or in the drawing, how do we represent the capacitor is like this. This is the capacitor. So almost all of the components here represented in the form of abstract, not the real form of that particular object. Okay. So can you name what type of software that is normally used for electronics drawing? So what type of software that we normally use for electronics drawing? For example, in the next page, we can see there are many softwares that can be used to produce the electronics drawings. One of the software that will be considered in this course is LT-SPICE. So LT-SPICE is a SPICE-based software, which is SPICE actually stands for SPICE. I don't remember. A SPICE is actually represent okay, SPICE. Most of the electronic design software is based on SPICE. SPICE is the simulation program with integrated circuit, meaning that the simulation program that considers the integrated circuit, which is IC. Yeah? So that is SPICE. So normally in electronic software, they are based on SPICE. Like for example, LT-SPICE is based on SPICE software. Another software that use SPICE-based platform is PSPICE, PSPICE. Okay, so these are the electronic drawing software that is available in the market that you can download it for free as well. For example, Easy ADA can be downloaded for free. That can be used to design the PCB board. So another software that is considered in this course is multi-sim lah, right? So we use multi-sim to design the electronic circuit and then to simulate it. So multi-sim is the product by National Instrument. So National Instrument is the company that produce multi-sim software. And basically, National Instrument also produce LabVIEW lah. LabVIEW is one of the powerful software. I think we don't have it in our university, LabVIEW. Actually, LabVIEW is the software that we can interact with actual, like for example, if we want to simulate the function of electric motor, we can use LabVIEW, and then we just click on that software so that we can operate that motor. So LabVIEW is one of the software that's produced by National Instrument. And then another software that we can consider to design the electronic circuit is FreeZine. FreeZine, we cannot clearly see the whole of this picture, right? It is actually FRITZING, FreeZine. So FreeZine is one of the software that is used to design the circuit, but it cannot simulate the circuit. Like LT-SPICE and multi-sim, we can simulate the circuit, but for FreeZine, we just can represent the schematic circuit and also breadboard circuit, but we cannot simulate them. Okay, so that is for some of the types of electronic drawing software that we can download it from. We can download and use it, and most of the software are free of charge, and then some of them are based on the developer-based software, which is open source. And some of the softwares, for example, multi-sim is software that we need to have a license to operate it. Okay, so this is the second part of this topic, which is about the 10 drawing sets. So the 10 drawing sets. So we have 10 sets of drawing that we can consider in every step of product development or electronic project development. For example, we have design drawings and also working schematic drawings. So for this design drawing and working schematic drawing, it is covered under topic 1. Okay. For breadboard drawing, it will be covered in topic 3, which is on the experimental part. And then for PCB design, PCB artwork, and PCB fabrication, all of these 3 drawings will be covered in the topic 4, which is prototyping part 1. And then PCB assembly, sheet metal drawings. I don't know how to get back my pointer. I lost my pointer. Slideshow. How do I get back my pointer? Never mind. Right. So, and the rest from PCB assembly, sheet metal drawings, wiring diagram, and final packaging. All of these 4 drawings will be covered under topic 5, which is prototyping part 2. So basically for design drawings, it consists of 3 types of drawings, which is the first one is system diagram. So system diagram is basically a sketch of a system. Normally when we start developing something, we have to do sketch. So it is actually the assembly, the flow chart, the flow of the system, right? So the first one is system diagram. The second one in the design drawing is the circuit design sketch, which is more to the schematic diagram of the circuit. We sketch it on a piece of paper just for conceptual. So basically in design drawing here, more on the conceptual based on the conceptual base lah. All right. And then the third one is packaging plan. Packaging plan is how do we plan our product, the final product, how does it looks like? So that is the packaging plan. Okay, from the 3 drawing sets in design drawing here, some of the drawing will go to the next section, the next level. For example, for the circuit design sketch will be further improve to form a more valuable, a more meaningful drawing, which is the working schematic drawings. Similarly, for the packaging plan, in the next step, it will be transformed into final packaging drawing. So let's have a look at the every part of the 10 drawing sets. Okay, the first one is design drawing. So in design drawing, as I mentioned earlier, there are 3 drawings considered in the design drawing. The first one is the system diagram. So this is a figure of the system diagram. For example, if you want to produce an amplifier, for example, we have the microphone as input, and then the circuit and the rest are output. So this is a microphone and loudspeaker based system, which is the audio amplifier system. So this is basically the representation in terms of system diagram. So this is actually the concept only, right? So the second one is circuit design sketch, which looks like this. So this is the circuit design sketch of the audio amplifier system that we have here. And basically the circuit design sketch represent the schematic circuit lah. Okay, for example, we have all of the components here, like we have the comparator, ataupun this is the operational amplifier, the resistor, potentiometer or variable resistor here, and then we have the capacitor, and the rest are resistor, battery, and so on. We have the speaker here. So this is basically the representation of the circuit design sketch. And then the third one is packaging plan, which is we design For example, the final product should look like this. The final product of an audio amplifier should look like this. So we design it so that it will become like this, right? So basically, in the design drawing, there are 3 design drawings. And all of this design drawing is actually the concept. It's more to the concept. And normally in this stage, we also produce the requirement document. So in the next step, for example, based on this conceptual design, we'll be moving on the more formal working schematic drawing lah. And then from the circuit design sketch we will form the formal working schematic drawing. Also similarly for the packaging plan, the next step is we do the final packaging drawing. So this is an example of the system diagram. So this is drawing of the system diagram. Okay, so we have, for example, input here, and then the system itself, which is that consists of circuit inside it, and then also the output. For example, at the input, we have the audio input, like voice input, a mic, for example. This is an example of the input. And then we have the circuit. The output in terms of lights. So this is an example of the 3-channel color organ. Yeah, 3-channel color organ ni macam it's like the circuit can produce the dancing light. Okay. So if you like to know more about the color organ, you can refer to this YouTube channel. I attach the link here that you can further explore what is actually the 3-channel color organ. And then the second one of the design drawing is the circuit design sketch. So this is just a sketch, but actually it is produced by using software. All right. So it represents all of the components on it and how we connect all of those components. So basically, we can use software like FreeZing to produce the circuit design sketch. So FreeZing, as I said before, FreeZing only can sketch the circuit, but not to simulate the circuit. For example, we cannot do the simulation of the circuit. For example, if we cannot just click on the switch and then it will operate. No, it's just to design the circuit. Okay, we just place the component and connect all of the wires just for design purpose. All right. So it is more to the conceptual based design that we use FreeZing. But in a more complex project, normally we don't end up with FreeZing lah. Basically, in more complex project, we'll be using software like SPICE-based software. So the next one, which is the third one, is packaging plan. So as you can see, the packaging plan is actually the representation in terms of drawing how our project looks like from outside. All right. For example, front view of the potentiometer, or front view of the audio, our 3-channel color organ itu, the front view should look like this. It has some potentiometer, which is the metering, yeah? And then it also has some switches. And from the back, we can see that there is some AC sockets over there. And then also the phone, RCA phone jack, the audio jack. And then also the AC line cord at the back. And then also in this drawing, we can also refer how do we complete our project in terms of painting, in terms of finishing of the product. For example, if we want to use varnish or paint, yeah? So all of the information about our finished product or about our finished project is given in the packaging plan. Okay, the second drawing in 10 drawing set is working schematic drawing. So the working schematic drawing is like a blueprint. It's like a blueprint. It is the most important drawing that illustrate precise and readable, meaning that it must be fully functional drawing. And it shows the circuit that consists of the component and how it is connected. And then in this working schematic drawing, it differs from the circuit design sketch in the design drawing lah, because in the design drawing is more to the conceptual, but in the working schematic drawing, it is actually a fully functioning, meaning that it is clear, it is something that understandable, meaning that if we everyone like design engineer do the design, but for those operating in the operation, for example, mechanical, for those working in the operation lah, like electrical engineer in the field, when they refer to that drawing, they understand, right? So it is more to something that is complete, right? So this is some of the this is an example of the working schematic drawings. As you can see in the working schematic drawings, it's more precise in terms of presentation. For example, some of the components here is also included with the rating in terms of wattage. The watt rating ataupun kita panggil the power of the component. So the power of each of the component is also displayed here. Not only, as you can see, this is the sketch, only the sketch. But for this one, it is also attached with the list of the components. As you can see, some of the components is clearly given here. For example, resistor with part number, and then also the capacitor, and rating in terms of wattage. So next, number 3 out of 10 drawing set is breadboard drawing. So breadboard drawing normally shows the layout of the component on a breadboard. For example, we have the breadboard, and we want to assemble the component on the actual breadboard. So we refer to the breadboard drawings lah. All right. So for the breadboard drawing is actual component. For example, we can use freezing. Freezing-based software can be used to sketch or to produce a breadboard drawing. And sometimes traditional approach, normally engineers use graph paper, not the software-based drawing, but they use the graph paper or grid paper to sketch or to do the drawing. Okay, so this is an example of the breadboard drawing. As you can see, most of the components, most of the electronic components are placed at the middle of the breadboard. So I'm holding the breadboard here. Most of the components, we place the components at the middle, okay? And then the rest at the side of this breadboard, normally it will be connected to the output, the outer component, the component that is not placed on the breadboard. For example, SO3 this one is actually represent the power source. Okay, so this is the power source that will be connected to the power source lah. And then the rest are all the components. And R3, R4, R5 is actually the output, which is speaker, I guess. Okay. Some of the examples of the breadboard drawing. As you can see, most of the components on this breadboard is placed at the middle of the breadboard. And then the rest, for example, this blue wire and green wire here will be connected to the source. All right. Okay. So similarly for the bottom one, this is the breadboard that is drawn to represent a circuit with Arduino Uno. So as you can see, there are switches placed in the middle of the breadboard and some of the wires connected to the Arduino. Okay. And then number 4 is printed circuit board design layout drawings. Ataupun this one we call it as PCB board design layout drawings. So normally PCB board design layout drawing ini we draw it on a grid paper. Okay, on a piece of paper with grid. So we can draw the PCB board design layout drawing. But some of the approach, we can use software. We can use software to do the PCB design layout drawings. So in the PCB design layout drawing, it normally shows the sketch of the component, layout and traces patterns. Component layout means the layout of the component, like capacitor component. It will looks like the square, the box that we can place the component like capacitor. And also traces pattern. Traces pattern means the circuit for current flowing on it. For example, traces for example, if we see so for example, in this PCB image, the traces is the green lines. This is the traces. Okay. Okay, the green line is the traces, which is the current from this IC, for example, will be flowing through these traces, right? Breadboard mana? PCB design layout drawing. This is the example of the actual drawing of the PCB design layout drawing. So as you can see from this PCB design layout drawings, it shows some through holes. The holes that we make on the board. Okay. And then, for example, this image represent the transformer. So from this drawing, we will know that this is a transformer, for example. This is SCR, the silicon control rectifier. And then this part is fuse. So, for example, this part is fuse. So from this drawing, we will know that this is the resistor. And then there's also the supply, power supply at the bottom of this drawing. So number 5 is printed circuit board artwork drawing, PCB artwork. So what is PCB artwork ni? So PCB artwork is actually its actual traces and parts of PCB design layout. The artwork is actually the negative film, that will be produced to be used in etching of the PCB. So in etching process, normally we use the PCB artwork, so that we can attach on the PCB the copper clad, kita panggil, the copper clad. We attach the PCB artwork so that we can expose it to the yellow lights ataupun kita panggil to UV lah, to the UV. So that the etching process will be before the etching process lah. So PCB artwork, that is why we call it printed circuit board. Printing, it comes from the word printing, meaning that, for example, if we want to design something on our shirt, we will use the negative film so that we can print the paint on that negative film to produce the artwork on our shirt, right? So it's very similar to this PCB based design. So we use the PCB artwork to produce, which is the negative film that is used before we etching the PCB. We do the etching of the PCB, right? So this is the example of the PCB artwork drawings. As you can see, it is the backside of the PCB actually. That is why we call it as negative film. So from here, we can put it on the copper clad board so that we can expose to UV light. So some of the part the part that is not covered by the dark part will be etched, out. Okay, and then the sixth drawing set is printed circuit board fabrication drawing. This is actually more to mechanical drawings, which is, for example, on how do we make a hole? How do we make holes on that PCB? For example, to make holes on the PCB, there are several types of holes. For example, the holes that we make to screw the PCB, right? And then some of the holes that is made to put component lids on that hole. Okay, and then PCB fabrication drawing also represent on how do we produce the shape, for example, in terms of shape, and also it's mentioned here, along with hole size and quantities are given, and also in terms of size, dimension of the PCB. Okay, and also on PCB fabrication drawing also mention about type of material that is used for that PCB, copper clad, solder coating, silk screening, and so on. So this is an example of the PCB fabrication drawings. As you can see, for PCB fabrication drawing, it is detailed here, the size and dimension of this PCB. Okay, and some of the holes. For example, this hole is different to that hole. Okay, this could be the hole that is made for different part of a component. Okay, so for this one, for example, this is the hole that is used to put the screw on it, and the rest are the through hole, the through hole that is used to put the component. And as you can see, it is also mentioned on this drawing about the dimensions, in inches, inchy, I guess, inch, I think inch, okay. And then the seventh one is PCB board assembly drawings. So PCB board assembly drawings actually shows where parts are placed and how they fit together. For example, we have the PCB board assembly drawing. We will know that which part we have to place that component. For example, for the capacitor here, when we refer to the PCB board assembly drawing, we will know that where do we can place this component, this capacitor. So it is basically the layout of electronic component over the screen image of the PCB traces. So as you can see in this example, for example, the fuse. This is the place that we can place the fuse. Okay. This is the location that we can place the transformer. All right. And there are some other places that we can put on the resistor, capacitor, silicon control rectifier, and so on. And then number 8 is the sheet metal drawings. So sheet metal drawing is actually not about the circuit, but it's more to the enclosure. How do we develop, or how do we design the metal chassis or enclosure of our project? So it is basically from the outside. How does our project looks like lah? So this is basically we can use the different software, not the circuit design software, but different software, which is more to the mechanical software we can use to design our sheet metal drawings. So this is the sheet metal. For example, if we want to design the our dancing lights organ. If we want to design our organ, this is actually how the organ looks like from the outside. All right. So this is basically more to the mechanical. So as you can see, for this 3D image, we can use this drawing in the form of 2D image that we can fold it. It has some folding lines here, some holes. So dimensions of these drawings. Okay, this is the sheet metal drawings example. As you can see, there are some folding lines. This is the folding lines. And some dimensions of the holes. And then material type also is mentioned in this drawing. How do we finish our end product? Okay. For example, it is written here. The finishing by using paint. And what type of color? The color that we are going to paint our project or our product. And then wiring diagram. So wiring diagram is actually, it shows the off-board wiring. Off-board wiring means that we have the PCB and then the out of the PCB punya wiring. Okay. So from that PCB, we can see the connections to the external parts of the PCB. But in a complex project, the wiring plan may be pictorial. Okay, so in a complex project, not a simple project, normally the wiring diagram will be shown in a pictorial. But in a simple project, normally we represent the wires in the form of schematics. So in the form of horizontal or vertical lines, like this. So this is the example. This is an example of the wiring diagram. As you can see, there are some external components that is connected by the wires. All right. Some of the wiring that goes to the source. Some of the wiring that goes to the switch. Wiring that goes to the jumper. and also wirings that is connected to R5, R4, R3. I think this one is more to the buzzer or speaker. And also this one is also switch wiring. Okay. And then the final drawing is final packaging drawing. So final packaging drawing is actually, it shows the final project. And then it is actually represent how does our project looks like from the outside. Okay. So for the final packaging drawing, we can see the location of the light, knob, switches, and so on. For example, from this figure, there are some, from outside, we can see that the connector for the power supply, okay, some knobs, switches, okay, displays, and so on. Okay, the next one is 2.3. So we finish all the 10 drawing sets. Now we move on to the drawing procedure. Yeah. So the drawing procedure actually, it shows the information on that drawing. For example, the person who prepared the drawings will be written on the drawings. And then sometimes we can see some things like the signature, okay? As you can see in this figure, the drawing check, okay? Also written. And title of the drawing, some memo or notes of the drawings, interconnections, right? The traces and pads of the circuit ataupun PCB board kita tu. And then borders and title blocks, reference designations. Okay, all of this information is called the drawing procedure. Okay. Okay. So we finish all of the slides given in this second topic, which is in this one is summary lah. So basically, things that we should know, things that we should learn from this slide is actually about 10 drawing sets itu. So that 10 drawing set is quite important in this course. So you should know each step of the process of the product development or PCB board design or electronic design. There are some drawings involved, including the design drawing, working schematic drawing, breadboard drawing, PCB design layout, PCB artwork drawings, PCB fabrication drawing, PCB assembly drawings, and also more to the mechanical, which is sheet metal drawings, and then the wiring diagram, which connects the PCB board to the external parts of the product that we want to produce. And then finally, the final packaging drawing, which is the representation of how our product looks like from outside. So that's all for the second topic. So that's all for the second topic. Okay, so I think it's a bit early today because I have things to do later. So we finish this class up to 6, up to 6 now, just 1 hour. Until we meet again later in the next week. As usual, I will communicate with you all through our WhatsApp group here. So if anything you have to ask me, you can personally text me or WhatsApp me, or you can ask in the group. Okay.
Doctor, so tomorrow no class morning?
What?
Tomorrow morning no class?
Tomorrow morning no class because we have already rescheduled the class.
Yeah.
Actually, tomorrow class from 8 to 9, we don't have class for this lecture.
Yeah. So sorry, doctor, this is our schedule for the, which days?
So actually, we
Ah.
have moved the tomorrow class 8 to 9 to today, meaning that today's class is actually from 5 to 7. Is it clear, Ali? Allah?
No, doctor, not very clear. Means weekly we have 2 sessions?
For today's class is actually straight 2 hours.
Okay.
So for tomorrow class, there will be no class because we have already rearranged the schedule.
Yeah.
And all of the students agree with that arrangement.
Yeah.
So we decide to continue today's class to do today's class from 5 to 7.
Yeah.
Clear, right?
Yeah, clear. So this week we don't have another session for this week.
For this week, only this session.
Yeah, yeah.
And
So
then about the practical,
yeah.
I will prepare the schedule for the practical after we finish all of the theoretical slide. After we finish all the theoretical topics,
yeah,
we will proceed to the practical.
Yeah. And doctor, our next session is the same time?
Yes, the same time.
Yeah, yeah.
Monday, 5 to 7.
Yeah, yeah.
Okay, clear, Allah?
Yeah, clear, doctor.
How do I pronounce your name? Allah?
Yeah, Ada, Ada.
Ada.
Ala. Same like Ali. Ala.
Allah. Ain. Allah.
Ain. Yes, correct. Ala.
Yeah.
Yes.
Okay, fine.
Yeah.
Okay, if anything you like to ask, you can personally text me or you can just drop WhatsApp to me.
Yeah, thank you, doctor.
Okay.
Yeah.
So thank you so much, everyone.
Yeah.
So we finish up to this time because I have things to do later. Okay, we'll still till we meet again in the next session in next week, Monday, 5 o'clock. All right. Okay, thank you. Terima kasih semua.
Thank you, doctor.
Terima kasih, doktor.
Thank you, doctor.
Sama. Sama-sama.